square root radical functions here. All right, so right here, the positive regions of a functions are those intervals where a function is above the x-axis. So everything up here is called the positive region of our function, if we had a function graphed, of course. So all of these values above the x-axis are going to give us positive y values. That's what we're looking for, is where the y values are positive, not 0, so that's why we have this marked off here. If it's on the x-axis, then we don't want to include it. All right, and then the negative regions of a function are those intervals where the function is below the x-axis. So any part of our function that is below the x-axis is going to be our negative region, because all of the values of y are negative down here below the x-axis. Okay, so let's see, I left a little note for you at the bottom here. For example, it says, where are the negative intervals? Well, we're going to look for a starting and ending point. When you're doing interval notation, you have a start point and an end point. When it's just inequality notation, then you can just do x is less than or x is greater than, whatever. But anyway, we're looking for the starting and ending values of x that will match up with negative y values on the graphed function. And if we're talking about positive intervals, it would be starting and ending values of x that's going to match up with positive y values on your graphed function. Okay, so let's look and see what that looks like. All right, this is quadrant 2. The entire function is in quadrant 2. It is literally starting here on the y-axis at that location, which is 0, 1. The value of the y-intercept right there is at 0, 1. So every part of this function is entirely going to be positive y values. So over the entire domain of our graphed function here. And this domain consists of all of these x values, right? From the 0 all the way this way to negative infinity. All right, so if we're going to write that in inequality notation, we would just say all x values that are less than or equal to 0 are going to produce our positive parts of our graph, because it's the entire graph. We do include the 0 because the value of y is 1, which is a positive number when x is 0. Here's your interval notation, and it's saying from negative infinity, you always put your smallest number first, all the way to the 0, which we have the bracket on. That means included, just like this little line down here means or equal to. All right, so that's what all positive looks like. Here's a graphed function, all negative. All of these y values associated with the entire domain here is in the negative part of our coordinate plane. All values of y are negative down here. Okay, so 0, the value of y is 0, so we can't include it, but we're going to start there, and then our values go to 1, everything in between 0 and 1, and then it goes on to 2, everything in between 1 and 2, you would go down in the negatives to get to the y values, okay? So like that would be 1, negative 1. This one right here would be 4, negative 2. All right, so how do we write that? Once again, inequality notation, we're saying all values of x that are greater than 0. We can't include the 0 because the value of y right there is actually 0. It's right there on the line, so you can't include anything on the x-axis. And then in interval notation, the smallest number, a part of our domain, is 0. We put a parenthesis because we're not going to actually include the value of 0, but every single number, including those little decimals and fractions after it, are a part of this domain that are going to give us these negative y values that match up. And we're going to keep on going until we, till the end of time, till we have exhausted our energy to ask about x values here. That's what infinity implies. All right, and then finally, here's an example of what you would see if part of your function is y values being negative, and then the other part of your function, your y values, are positive. So you can see from this piece right here, where our x is negative 5, right there, all the way to the x-intercept of -1. So all of these x values right here are going to match up with negative y values. So from -5 being the smallest, and we're going to include it because the value of y is a -2 there, all the way to the x-intercept of -1, which we won't include because the value of y is 0 there. So that's going to be our negative interval, and that's what we have down here, where x is greater than or equal to -5. That's going this direction. And at the same time, it has to be less than the value of 1, not to include 1. That's why there's no equal to. And then this is what it would look like in interval notation, or starting or stopping numbers. So from -5 to -1, a parenthesis because we're not including the -1. And then as far as positive, we're going to pick up right there at the x-intercept. Once again, not including the x-intercept, but all of these x values right here, all the way to infinity, are going to produce the rest of these positive intervals. Positive y values. So our positive intervals from our -1, not to include him, all the way to positive infinity. And that's what it looks like down here. X values greater than the -1, but at the same time less than positive infinity. So that talks about from here all the way to infinity. And then here it is in interval notation. We don't include it, so that's why we put the parenthesis. And then we go all the way to infinity. All right, and here's a quick little hint. The secret to correctly stating the intervals where a function is positive or negative is to remember that the intervals always pertain to the location of your x values. Think of reading the graph from left to right along the x-axis. You're not going to read any numbers off of the y-axis to write down for your intervals, okay? Stay on the x-axis. You're just going to look at the graph to find what values of y are positive or what values of y are negative, and that's what you're going to be recording. All right, good luck. Let me know if you have any questions.